Hey everyone, welcome back to my channel EduVibe. In today's lesson, we are doing the next topic of the unit C, which is the parts per million concentration. And this is grade 11 chemistry, and we are doing the unit third of the grade 11 chemistry. Today we're doing the parts per million concentration, which is again the topic connected to the other topics, but not the connective. We use different formulas in this, but that is the concentration part. In the previous lessons, we do the molar concentration, we done the percent concentration. Now we're doing the last concentration, which is the parts per million concentration. We involve the unit analysis in this, but also we have some formulas to be know in this too. So let's start with the what is parts per million. Parts per million concentration is the number of the units of the mass of solute per million units of the total solution. Why they use a million? Because 10 raised to power 6 is the 1 million. So parts per million concentration is basically the number of units. If you have a number of units of the mass of the solute, we involve the mass in this, which is the per million units of the total solution. What's that? So basically, we have these two formulas in this. These are in the grams and grams, and we have a grams per million milliliters, and that we have basically two formulas, and these two formulas are ultimately in these two formulas are ultimately related to these two. Because here we use gram and grams, here we use the mg upon kgs. These are the gain the unit, mg is again the unit of the mass, and the instead of the gram per milliliter we use mg upon liters. So you have to take care of these things, that why we using this. We use the m in this. Why we use this m in this? Because of the that 10 raised to power 6, that rid of this 10 raised to power 6, that's why we can use. Mostly we use this thing more. We use these two formulas more because they don't have included in the 10 raised to power 6. So we use these two formulas more in this unit. If you want to use these two, you can use. It's up to you. So let's start with the first example. So in a chemical analysis of the 250 ml of water at SATP, 2.2 mg of oxygen was measured. You have to calculate the concentration of the oxygen in parts per million. Basically, we have to use the ppm, and they involve the volume and they involve the mass. So basically, this is the mass and volume thing. The mass of the solute, volume of the solution, that all things are same as we did in the percentage concentration. But this involve only mass and mass and mass and volume. Solute and solution. So in this, you have mg, which is the mass, which is right. We can use this, which get rid of the 10 raised to power 6. But we have a milliliter now. But the milliliter should be converted into liters, because over there you can see that with mg we have a liters. With grams we have milliliters, and but we involve the 10 raised to power 6. But with mg you have to be in liters. So you have to do some conversion, which we have to convert the volume into the liters. So we do mg upon liters in that case, which is 2.2 mg divided by 250 ml, multiply by, we have to like divide this or multiply this. You get this thing. Or you can do by your own, like do the separate things, and you can do. So up to yours. So that's you have, and you can get the rate of the ml. When you calculate this, you get about 8.8 ppm. There's no units depend on mg per milliliter. You can't write this. You have to write ppm, because we use then concentration in ppm thing. So that's how the parts per million concentration works. So you have to take care of the signs like this. Like in this question, this is again the conversion question we did in the percent concentration. You have to watch the percent concentration for this lesson, because that lesson is very important for this lesson. Convert 4500 ppm of NaCl aqueous to the molar concentration. So in mole per liter you want, but basically you have on the you are in the ppm. Now either you use mg per kgs, or you use mg per liters, but you have to ultimately convert into the mole per liter. For my convenience, you have to use the mg upon liters, because we want moles per liter and we already have the liters. So we also have to deal with only with the mg to convert into moles. So that was easy one. So I will take the mg dot liter, mg per liter to convert it into the mole per liter. So our goal is to convert into the moles per liter. So we have 4500 mg upon 1 liter. We query like that, like we do in the percent concentration for our convenience. Now you have to cut the mg. You have to know this, that 1 gram is equal to the 1000 mg. This is important thing. You have to know some conversions in this, except the kgs, grams, and milliliters and liters. Have to know this too. The 1 gram is equal to the 1000 mg. From here, the mg cancel out. Now you want the moles in the numerator. So NaCl. So you can calculate the molar mass of NaCl. So 22.99 plus 35.45, you will get 58.44 grams per mole. So you got moles up. So 1 mole is equal to 58.44 grams. The grams and grams are cancelled out. So 0.077 moles per liter when you calculate this all thing. Basically the 0.7700 moles per liter. You want like 4 siddhis. Make sure about the siddhis. Siddhis are very important. We have a 3 siddhis in question, 4 siddhis in question, so we have left with the 4 siddhis. You know, in the point thing, the things after the decimal, that's your significant digits. This is 4. So that's how you can do the conversion from the ppm to moles per liter. Again, very important, like we're doing from the percent to the moles per liter. This is very important. Let's do one more question. The question says, the hard water contains up to 300 ppm of the calcium carbonate. What is the mass of the calcium carbonate is present in 20 liters of hard water with the maximum concentration of the calcium carbonate? So you have to find the mass, and we have given the calcium carbonate and we have a hard water. As you all know that hard water and water is at like the solution, so we have the mass of the solution, although you can say volume of the solution because of liters. So we have a volume of the solution and we have to find the mass of the solute, which is the sodium carbonate, and we given the ppm thing, which is 300. So you can use mg per liters because we have liters, that's why. So 300 mg per liter is equal to the mass of the solute divided by the volume of the solution, which is 20 liters. So 300 mg upon liters multiplied by 20 liters is equal to the mass of the solute. Liters cancel out. You will get a mass of solute of about 6000 mg. Yeah? So the mass of the solute is equal to 6000 mg. Multiply this by, because you want this in grams, because this is very long thing, so convert it to grams, which more like a good answer you get. So you know 1 gram is 1000 mg. Over there we discuss the conversion is very important in this. And when you do this, so mg cancel out, you get mass per solute of 6.0 grams. You want to say this, so 6.0 gram is your answer as the mass of the calcium carbonate, which is the solute. So that's how the ppm works. We do all kind of questions which are very important for your understanding of this topic. So we've done all the concentrations thing, molar concentration, percent concentration, and now the ppm, which is the parts per million concentration. Now we do the concentration of the ions with all 3 things. That we do in the next lesson. For now, this all for this lesson. Let me swear to EduVibe learn smart not harder. Please like, share, and subscribe to my channel. If you have any questions, let me know in the comment section. See you in the next lesson. Take care, stay creative with EduVibe.